floor is yours.
Hello everyone. In this webinar we're going to talk about vibration testing in aerospace, and we will discuss standards in this sphere, technical specifications, types of setups, and most common test types. We're hoping to make this webinar interesting and worthwhile. And here you see that at first we're going to talk why do we need testing in aerospace, discuss main source of vibration, discover the factors and ways of testing. We will talk a little bit about test standards. I'll give you some test examples, and I think now we can start. And our first topic is why do we need vibration testing in aerospace sphere? In general, an aerospace system usually consists of a space or air vehicle, for example, satellite or some kind of spacecraft, its launch system, or some kind of air vehicle. It can be a helicopter or plane. A vehicle is an integrated set of subsystems, its components, and its engines. Also, an aircraft vehicle may have some kind of a payload or special equipment which must be delivered safely. Certification and the design of the aircraft system and its components is really important, and the purpose of the design certification testing is to ensure that verification demonstrates design compliance with functional and performance requirements. As much as possible, this testing process simulate natural and natural events by influencing the different parts of a vehicle or the vehicle itself. And also we can divide the process into 3 repetitive steps. On the first one, we make design and analysis. After that, we verify and validate our testing object. And after that, we check the requirements and specifications. These 3 steps will be repeated until we reach the desired quality of our object. Also, we can apply vibration tests while running some kind of fixture tests, acoustic vibration tests, aerodynamic tests. Also, using our software, we can perform durability and structural analysis using model analysis software. And in RULA, we can cover mostly all application spheres of aerospace testing. Now let's talk a little bit about sources of vibration. There are 3 main sources. The first one is acoustic vibrations. They represent the influence of the sound field of an engine or some kind of part movement, fuel flow, and fuel combustion. And this sound field can generate vibration impact on all other parts of our aerospace system. Also, we have aerodynamic vibration. It's an environmental influence during the flight, and this influence can cause some flutter in the airstream, turbulence, oscillation shocks, and high velocity flow on the engine and its parts. And finally, we have mechanical vibration. It's an influence from our equipment or payload. For example, it can be a mechanical release during the launch or some separations from spacecraft. Here you can see main factors for vibration testing. Firstly, we need to check the materials for production, their strength, their durability. Also, we need to control the fabrication process to check its quality. After that, we need to check all kind of load variants for our spacecraft engine or vehicle. After that, we need to check all environment specifications, for example, the temperature and humidity influence on our object. And of course, we need to make structural design to find the weakest parts of our object. And finally, we calculate cost, schedule, and risk for our object. There are three main ways of vibration testing in aerospace. The first one is fixture testing. Usually, this fixtures for aerospace are designed to handle with all kind of resonances and resonance frequencies below 500 Hertz and minimize all other resonances. In that case, we need to include multiple axis vibration tests. For example, we have in RULA multi-shaker tests, and we need to test our object at different levels. By levels, I mean the vibration load and amplitude levels in our software and different conditions. In that case, I mean that device under test must be checked at different development and operational stages and time periods. After that, we can perform data recording and analysis. We have a special software for this. We have spectral analysis, octave analysis. Now we develop model analysis, and soon we will have a model hammer option. And finally, we have another way of testing. It's product testing. This way of testing includes development, qualification, acceptance for all prototypes and flight models. This final step can be divided into prototype testing and protoflights testing. Both of them have the main sub-step, which is called development testing. In that case, we test our prototype or protoflight model during its development process. And if we have our prototype model, it goes to the next testing steps, which is qualification and acceptance. All these steps can be divided into flight testing, model analysis, acoustic, sign, random, and shock tests. But as you see, we have the same, I can say, names for these steps. But for example, prototype at development step will have different sign testing than a prototype model at acceptance step. So you need to know that all these tests will be different at all steps of the development. Here you can see the main table which shows the difference between the dynamic tests. Here we have acoustic, random, sign, flight test, and shock. You can see the purpose of this testing, the most sensitive equipment parts during this test which must be tested, the main frequency ranges, and the risk of failure. So looking at this table, you can see that during the sign test, we will check the workmanship and qualification of sensitive equipment. Sign test will be running at the frequency range of 5 to 100 Hertz. And In this way, our object under test will be some kind of interfaces and primary and secondary structure. So also we can see that at shock test, we are going to test only electronics and the packaging and load for our system. Here you see the basic standards in aerospace sphere. For example, we have our British standard for environmental testing, US Air Force Space Command standards, some kind of INA, NASA standards for vibroacoustic testing, and also we have well-known MIL STD, it's military standards, which can be applied for environmental and structural testing. Here we will talk a little bit about our setup. I'll turn on the web camera. I hope you can see it. Please type something if the quality of the video is really bad, but I think you see it correctly. So here you can see that we have our regular shaker. On its top, we placed a plain model on a special table. On the shaker's table, we mounted 10 millivolts per G accelerometer. On one wing, you can't see it, it's on the back side of the plane. We have also another accelerometer, it's 100 millivolts per G. Also today we are using a laser vibrometer. You can see the part and the fixture of it. And we have our regular controller, RLC21 and RLA200 amplifier. Today we will discuss 4 main test types in aerospace. It's sign, shock, fatigue, and random. And now let's go to our software module here, and let's start with our regular sign test. Before we start, I need to show that I created a special channel settings. It's called webinar. We have 10 millivolts per G IP sensor on the first channel. It will be our control one. On the one side of the plane, we have 100 millivolts per G IP accelerometer. And on the third channel, we have 17 millivolts per millimeter laser vibrometer. It has a linear sensor type because it has external power supply. So let's go to the main tab. Here we will press create test. As we know from the table, we need to run from low frequencies to 100 Hz, and today we will start with 10 Hz and go to up to 100 Hz. We will start with 0.5 G up to 1 G. After that, we go to schedule, check that we have only one command. It's called run profile. We'll go straight from the start frequency up to the end frequency. After that, we go to limits. Here you see that we have Tiro TV 51110 shaker, and in channels, we select our webinar configuration and disable the 4th channel. And let's apply the settings. And now let me turn on the amplifier. I set the gain to 25% and now we're ready to start. Let's start the test. And let's open another graph. It's called transmissibility versus frequency. And using this graph, we will check the resonances using the laser vibrometer. So here you see that our main sensor, the red line, is running really close to the profile. And here, using the laser vibrometer, it's the pink line, we will detect some resonances here. Let's wait some time. I hope you see that our plane is shaking really hard. And we mounted this plane model using the rubber bands because I wanted to make this structure harder. And I think now you can see the resonance in the front of the plane. And let's auto scale the graphs. And now we have a resonance on the right wing. And here on the transmissibility graph, you can see that we have the increase of transmissibility and some peaks on the graph. That means here that the acceleration on the wing is higher than on the shaker stable. Here we have a decrease in acceleration. And let's check the questions while we're running the test.
Yeah, so we actually have a question. Can we control sign test using laser vibrometer?
Yes, we have such feature on sign and sign-based tests. So you can select your laser vibrometer or some kind of laser sensor as a control one.
Mm-hmm.
And let's go back to the graph. Here you see that we get more peaks on the graph. And after the test is complete, we will discuss these graphs a little bit. I think we're really close to the end of the test, and let's talk about this peak. You can see that its transmissibility value is much higher than on all other frequencies, so we can suppose that we have a resonance in some kind of frequency between 70 and 80. Let's create a vertical cursor line. And here you see that we got a resonance at 75 Hertz. And here on the graph, you see that we got an acceleration increase at 75 Hertz here. In that case, using sign test, you can influence your object with a regular sine signal, find resonances, and about resonances we will talk in the next software module. And now I think we can go to random testing. Here we change the test. And let's create a new test. Today we will run from 20 Hertz according to the table up to 500 Hertz. And I want my acceleration to be about 1g, so I enter this value here and press recalculation. After that, in schedule, we have one run command. We will run the test for 1 minute. In limits, we have our TIRA TV51110, and in channels, we set webinar configuration. And here we are not going to use our laser vibrometer, so I disable it. And we have only 2 accelerometers. Let's apply the settings. Also, you see that during this test, you cannot use non-accelerometer sensors. So let's go to channels configuration and change it. We'll set it as acceleration, but we will change it back to displacement sensor when we will go to fatigue testing. Let's apply it. And here we have 2 sensors. Let's apply the settings. And start the test. And here you will see that using random test and spectrum density versus frequency graph, you can also detect resonances on your structure. You'll see some peaks on the graph. And now we're waiting for the startup. And before we started to run the test, let's check the questions.
So actually, does your software have an option or mode in which you can influence your object with multiple sine tones instead of just one?
Yeah, I'll show you this feature when I'll show fatigue test, and I'll describe the multi-tone run and advanced sine module, but I'll make it a little bit later. Is it okay? I think that will be okay. And here, let's go back to our graph, create a vertical cursor line. And here, using our second accelerometer, which is placed on one wing, we can see that we get a resonance at 208 Hertz, like here. And you see that here we will get the anti-resonances. And using random tests, you can replicate real-life events. For example, using some standards, you can simulate some explosions, road shaking, some turbulence, and there are a lot of standards here. And here in the create test, we have an ability to create tests from templates. And if you wish, you can send us the files and we will add them to the templates.
Oh yeah, we have another question. Yeah. So can you show FRF amplitude and phase graph? Yes.
Okay. FRF and phase. And to see the FRF graph, I'll run the test again. Because it's calculated during the test run. And the phase also shown here. Here you see the phase on the second channel and the FRF on both channels.
Yeah, thank you.
So I stop the test. And now we will go to shock test. And in shock test, we will create a test based on MIL-STD profile. Here we have MIL-STD 810G. We select terminal peak, press OK. I'm really sorry for the noise if you hear it. And here in the settings, we go to schedule. We will have 10 shocks. Let's set the value to 150%, and we will set it as manual. So that means that every time I press the shock button, our system will perform a shock impact. After that, we set auto sample rate. And here we need to select our Tiro shaker. Here you see a lot of warnings. That's because we created only test profile and we don't have the basic channels configuration or shaker for the template test. So you'll see a lot of warnings. That's okay, because you need to configure the setup manually for template tests. And here we also disable the channels, the third and the fourth. And let's apply the test. After that, we start. Wait for the startup. Let's start it again. Here you see the shock button, and let's press it. And I hope you'll see the shock. Let's make 10 shocks.
Yeah, actually another question. So one of our viewers is interested in SRS. So could you maybe showcase the module, how it works?
Yeah. Let's finish with the shock, and I'll describe the other two shock test options. So here we performed our 10 shocks. The test is stopped. And let's see. Also, in our software, we have an SRS and TTH modules. They are both based on shock test, but in SRS, we can influence our object with shock response spectrum. I'll show you in the settings. You can enter the SRS table, SRS parameters, synthesize the signal, enter the wavelets, and this test is really useful. And I need to mention that we have a multi-shaker option for this test. And about TTH, this test can be performed in multiple ways. For example, we have some shock waveforms that cannot be included in regular shock or SRS test. And here we have cosine shock, damped sine wave, teardrop, sine chirps, square waves, random shocks. We can also import a shock signal from file. In that case, you can create a shock with the waveform which you like. And we have a lot of options here. And I need to mention that both TTH and shock test have some SRS table options here. They are disabled by default, but you can enter SRS table and SRS parameters for these tests.
Yeah, I need to mention that we also did a webinar on SRS, TTH, and shock tests in particular. So we covered them in detail and we did a live demonstration. So I will send the link to everyone who is interested. But basically, just to save time, today we'll cover the rest of the options we wanted to cover, including the fatigue tests.
And finally, before we start with fatigue test, I'll answer the question about multi-sign. Here we have an advanced sign module. And here in the schedule, we can create a multi-tone sweep. That means we will influence our shaker with multiple sign tones with different frequencies at the same time. Here you can see that you can enter the number, and also we have a stepped sweep. That means we will run the sign for some time and after that keep it on pause. And another interesting option is called multi-sign. We enter multi-sign command, add, for example, 3 sweeps, and enter and multi-sign. Here we can select different commands, enter their parameters, and using multi-sign mode, you'll see that all of these commands between multi-sign and end multi-sign will run at the same time. So, for example, this feature is widely used, as I know, in automotive because it saves time. And some companies have advanced sign usage in their inner standards. And let's talk a little bit about fatigue test. We will use the same test profile from the regular sign test. We will run from 10 to 100 Hertz, from 0.5 to 1 G. Here we will set run profile, and to find all the resonances, I will add search for resonance command. After that, let's check the limits, and in channels, let's change our third channel sensor. It is displacement, and its sensitivity is 17 millivolts per millimeter. After that, we disable the fourth channel and go back to Resonance Search tab. Here you see that we need to select the reference channel. We will use the first one because it's the control, and response channels. These two channels, the second and the third, will be compared with the first channel, and the transmissibility will be calculated. Here you see all other kind of resonance search settings, but we have a large webinar about sign, resonance search, and fatigue. All these options are described there. If you need, we will share a link. And now I think we can apply the settings. And start the test. Let's open before we start the transmissibility versus frequency. And now our test is running. And here on the right side, you'll see the transmissibility and acceleration graphs. We need to wait some time, but let me check the questions.
Yeah, let me check. So, do you have an ability to replicate turbulence?
It's an interesting question, and let me think. Personally, I can advise you to use two vibration test options in case you know some standards for turbulence testing and you know the profiles. You can try to simulate it using the random test. And for example, if you have a data recording of turbulence, you can replicate it in our field data replication module. And if you want to test the durability of your testing object, we have another interesting feature which is called fatigue damage spectrum. We talked about it in our previous webinars. This feature allows you to replicate a real life event, which is usually can take some, for example, 3 months. But using this option, it will be recalculated into another profile, and we can change, for example, as I mentioned, 3 months into 1 hour vibration test. And for example, we can check the durability of our testing objects using this feature. Here, let's go back to our graphs. You see that we got transmissibility decrease on our laser vibrometer. And here, as in previous test, we're going to have a resonance at about 75 Hertz. Here we got the peak. And finally, when the test will be completed, you will see a table with all resonances found on all channels. So here you see that I think our resonance search settings will be a bit high for this search because we get a low transmissibility increase here, but you can always change them and try it again. And in that case, you will see that we have some resonances. You have different options for working on resonances. And personally, I recommend you to watch our resonances search webinar. It was rather interesting and it is useful. And I think now I want to tell you a little bit more about one interesting feature. It is called notching limits. We have this option in sign random shock and sign random on random test. Let me describe it in an example. Let's open the settings, set another configuration because of the warnings. And here in the limits, you see main limits tab and notch limits. That means that for every channel you can set the upper and lower limit. For example, you can set the limit at decibels or table like this. And if during the test your signal goes higher or lower than the limit, the signal will be automatically decreased or increased in case of lower limit. And that's very useful during the test process of long objects. For example, you have one shaker, we have some kind of a beam on it, and we have 3 sensors, one in the center, 2 on the sides. And during the test, you'll see that the acceleration on all these 3 points is different. And for example, one of the sides can be damaged during the test. In that case, you set the upper notching limit of that sensor, and when during the test you reach the notching limit value, the test will decrease the level and you won't damage your object. And now I think that's all I wanted to show you in the software. So let's check the questions.
Okay, so I think we have another one. Can we set kurtosis in random tests?
Let's go back to our software. Here, control, as I showed in previous webinar, we have kurtosis checkbox here and its settings. You can see that you can enter its value and its gain.
Okay.
And so today we talked about vibration testing in all aerospace spheres and production steps. We decided and discovered that aerospace testing has complicated and repetitive vibration testing process. I showed you that using RULA devices and our software, you can perform all types of aerospace testing, and I showed you some most common test setups and vibration tests, which can be useful for you.